Alright, hey guys, how are you all doing? Let me just see if I'm live or not. If I'm live, I'll just quickly post this on Twitter as well. Come on, shit. Um, Alright. Um, just posting this on Twitter as well. Study with me. OS V1 page sent, liked, right? I'm like close. Yeah, guys. So today we'll be studying operating systems, and today we'll be studying OS. And all right, let's start with the theory, and then uh, let's start with the theory, and then we'll cover the interview questions. All right. So again, this is a concise version of the complete operating systems. If you want to, revise from scratch, that is every detail, then I suggest watching video of some other YouTubers. But because you won't be getting as much detail which you are expecting. But yeah, this is something which you can revise during placements or internships. It's like the most powerful notes of OS. Right. So let's start. So definition and purpose. So why do we need OS and what is its purpose? So what operating system does, it manages computer resources, provides environment for program execution, hides hardware complexity, acts as resource manager, facilitates app execution. So these are the purposes. This is the purpose of operating systems, to do all of this: hide, act, facilitate, manage computer resources. Now, why do we need operating system? Uh, so why OS? So operating system is made up of system software collection, that is collection of softwares which basically maintain a system. If we do not have an operating system, then what is going to happen is we are going to have bulky and complex apps that will exploit resources too much, and there would be no memory protection. So it is possible that that particular application is consuming the complete memory without giving memory to some other application. Now, what are operating system goals? The goals of operating system are simple: maximize CPU utilization, less process starvation, and third, high priority job execution. Now, types of operating systems. The goals of operating system are maximize utilization, less process starvation, higher process priority job execution. Now, types of operating system. We have single process operating system. Here only one process executes at a time in the ready queue. We'll come to this part later, like what is ready queue. Next is batch processing OS. Here user prepares jobs, punch cards. Okay, just a second. Yeah. Processes batch processing operating system. Here what happens is user prepares jobs, also known as punch cards. Then we have an operator which is basically kind of OS. What it does is it collects and sorts all the jobs into batches. The operator then submits these batches to the processor. All jobs in batch execute together. Now, what are the limitations? That priorities cannot be set. It may lead to starvation, and CPU will be idle during input output. So I'm just checking what is operator in batch processing OS. Human component. Okay, so operator is a human. All jobs in batch execute together. Now, limitations. Priorities cannot be set. In multi-programming operating system, what happens is increases CPU. In multi-programming operating system, what happens is CPU utilization increases. Multiple jobs in memory. Single CPU. Context switching when process waits. Reduced CPU idle time. I think that's fair and clear. We have multiple programs. What happens is those programs, when it is running, it is called process. So when any job is kind of in waiting state, then context switching happens and another process is worked upon. Increase CPU utilization. Now I'm given multitasking OS. It is a logical extension of multi-programming. Single CPU runs more than one task simultaneously. Context switching and time sharing are used. Increases responsiveness and further reduces CPU idle time. Next is multi-processing OS. This is multi-programming and this is multi-processing. So multi-processing means we have more than one CPU. It increases reliability in the sense if one processor fails, then we can have other process as well. When CPU fails, then other CPUs can handle the task. Better throughput. Throughput means the number of process completed per unit of time, and lesser process starvation. Now we have to last edge, that is distributed operating systems. Here many bunches of resources, more than one CPUs, more than one memory, more than one GPUs are managed. It is like loosely connected autonomous nodes in the sense we have many nodes present all over here, here, and those nodes are operating system in itself, but to manage all those nodes we have this distributed OS. You can consider this something like a graph in simple terms. It is a collection of independent network communicating and physically separate communicational nodes. Real-time operating system, it's real-time error-free computations within tight time boundaries, example air traffic control and robots. Now let us go to program, process and thread. Program, it is an executable file. It contains set of instructions for a specific job. It's a compiled code ready to execute and it is stored in disk. So what is program? It is an executable file stored in disk, compiled, it is ready to execute and it contains set of instructions for a particular job. Process is program under execution and resides in RAM. Okay. What about thread? Thread is a single sequence stream within a process. It has its own independent part of execution in process. It is lightweight. It achieves parallelism by dividing process tasks. Example, browser tabs, text editor features, spell check, format, save, content. Next we have what? Multitasking versus multi-threading. Next we have multitasking versus multi-threading. OS goal, single with background, particular one. You know what? I'll add diagrams as well so that you guys can understand it. Distributed OS. $300 multi-programming, multi-tasking, batch processing OS. Yeah, batch processing OS, you can see multi-programming, distributed is fine, process programming. Yeah, so as you can see in the diagram, we have this program which is inside my ROM, executable file. Now when I have to run this program, it goes to the process. Now I have another doubt over here. Program is under round. So when I write my C++ code, it is basically a program. So is it stored in ROM? And when execute my C++ code, what? Okay, so when you write your C++ program, that source code stored on your disk after compilation, it becomes program in ROM disk. Actually, instead of ROM, it is basically hard disk. And basically generating the image for that. In the meantime, I'll just see if I have any good diagrams as well. Let's continue to multi-threading versus multitasking in the meantime. So multitasking is execution of more than one task simultaneously. Concept of more than one process context switched. Number of CPUs are 1. Isolation and memory protection exist. OS allocates separate memory and resources per program. For example, I am playing a music and using my Word document. Next is multi-threading. Processes are divided into subtasks, threads. Each thread has its own execution path. Concept of more than one thread. Threads are context switched. Number of CPUs greater than or equal to 1. That is better with more than one. No isolation memory protection exists because threads are present in one process and they share common memory. OS allocates memory and process threads. OS allocates memory to process, threads share it. Example in Word, spell check runs by the type. Let me quickly see my diagram. Gemini. I'm using Nano Banana. No, not that right. I'm not finding any other good I think I found one. Oh, ByteByte Go. Nice. You can see the difference between program and process. Program is document, process is this running, and threads are internal things. Now I understood what is happening. So VS Code is a program inside. I have this C++ files which are processes basically, and it runs. Got it, got it. ByteByte Go. Man, this is so cool. ByteByte Go. Multitasking, what's the multi-threading we have covered. Thread scheduling is threads are scheduled for execution based on the priority. Each thread is assigned a priority level. Each thread is assigned a priority level. The OS uses these priorities to decide which thread gets CPU time first. Threads are scheduled for execution based on priority. Each thread is assigned a priority level. The OS uses these priorities to decide which threads get first CPU time. Higher priority threads are scheduled before lower ones. The OS allocates small chunks of CPU time to threads, ensuring that even lower priority threads get some execution time, especially in priority scheduling. Now we'll go for context switching. What is context switching? So basically we have two types of context switching. Context switching basically means that whenever a process is running and it happens that the process is in waiting state. So what the CPU who switches the context? The OS. The OS then switches the context in the sense it saves the current state of the program process in a buffer and it moves to some other process. It moves to execute some other process. This is what context switching is. Now we have two types, thread and process. In thread context switching, operating system saves current thread, switches to another in the same process. It doesn't include switching of memory address space, but program counter registers and stack are included. It is fast switching and CPU's cache state is preserved. Cache is basically that hold as the process is stored, right? In the sense, suppose I browsed google.com, now that is stored in my cache. In simple words, process context switching is saves process state, switches to another process, includes switching of memory address space. It is slow switching and CPU's cache state is first. So cache state point is something which I did not understand. CPU's cache state reserved. Threads of the same process share the same memory space. Means the data already in the cache is still valid for switching as faster. CPU cache state is flushed, is cleared. Because the new process may use a completely different memory space. Data and cache may no longer be valid. I hope this point is clear now. Code. I will just see the different types of operating system components. Oh my god. User shell. So we have 4 types: user, shell, kernel and hardware. I'm just seeing if I can get any diagram or not. Nothing I said. I mean, it's simple. You can see from arrow marks itself. So user space is where application software runs. The apps don't have privileged access here. It interacts with kernel. We have 2 types: graphical command interface and command line interface. Now we have shell. It's first part of OS to load on startup is kernel. Now we'll just see what are different kernel functions. The first one is process management, as you can see from the